Algebra 2, Chapter 3, Day 1. System of equations. Learning target. I will be able to solve systems of equations by graphing. So in linear system equations, we are putting in the equations that we learned from Chapter 2, the linear equations, more than one together to combine them and make them into systems of equations. We're going to try to work with them and see what does the solution set means in this type of equations. So first one is the order pair and element of the solution set for the system of equations show all work. So what does it mean by solution set? It simply means that if you plug in the numbers into the equations, it would satisfy the equations and the statement should be true. So let's go ahead and plug the numbers in. Remember, in an ordered pair, the first number is representing the x value. The second number is representing the y values. So this is the definition of a point ordered pair. First number is always the x. Second number always stands for y. So I'm going to directly plug it into the given equations. 2 minus 2 times 4 equals, so 2 minus 8. Which is -6. And it is indeed equal to -6 as given in the equation. So first one is true. How about the second one? When you're trying this type of question, you cannot jump into the conclusion. If your ordered pair satisfies the first equation, you will also have to check for the second one. So let's go ahead and do that. So y is 4, x is 2. Is 4 plus 2 equals 6? Yes, indeed it is. So this time it matches up with the second equation. So what can you say at this point? Because this ordered pair satisfies both equations, so we can say, yes, this point is a solution set for the linear system of equations. And only when after you plug it into both equations, it satisfies the equation, you can make this conclusion. Question number 2. Another point 3, 2. So don't forget the first number is your x, the second number is your y. So let's go ahead and plug the numbers in. 2 times 3 plus 3 times 2. Is it equal to 1? So 2 times 3, we have 6. 3 times 2, we have 6. 6 plus 6 is 12. So obviously it does not equal to 1. So the first equation, it's not a solution set already. The point is not a solution to the first equation. At this point, we can all go ahead and stop and say that the solution, the given pair 3, 2 is not a solution set. But since we're doing the demonstration, let's just continue and finish the second equation and try it. So 8 times 3 minus 6 times 2 is it equal to 24? So 8 times 3, I have 24, minus 6 times 2, I have 12. So 24 minus 12 is 12. So obviously it does not equal to 24. So both of the equations show that they do not satisfy the equations. So like I mentioned, if the first equation does not a solution set, you can go ahead and state, no, it is not a solution set. So as long as one of them is not a solution set, then you can say the conclusion, the given pair is not a solution set to the linear system of equations. It has to satisfy both. And one of them does not satisfy the equation, then the conclusion is no. Number 3, find the point of intersection by graphing. So you are given again linear system of equations. How do I find the intersections by graphing? So this one, you can either choose to use the slope-intercept form, or since we're already given this information in general form, we can go ahead and find the x-intercept, y-intercept point and graph. So how about let's just do it with the y-intercept format. So rewriting the equations into slope-intercept form. So first equation, 3x minus y equals -2. So I want to solve for y. So I'm going to subtract 3x to both sides. I have negative y equals negative 3x minus 2. And then I have to multiply both sides by negative 1. So y equals 3x plus 2. So that's our first equation in slope-intercept form. The second equation, x minus y equals negative 4. So do the same thing. I'm going to subtract x to both sides. So I have negative y equals negative x minus 4. Multiply both sides by negative 1. So I have y equals x plus 4. Now we have both equations in slope-intercept form. So let me just rewrite it down here so that you know what I'm doing. So y equals 3x plus 2. Y equals x plus 4. So first equation, y equals 3x plus 2. I'm going to draw in black color. So with the y-intercept point located at positive 2, so again, the constant shows me the y-intercept point. The slope is 3, so right 1, up 3 to find my second point. And then I can make my graph. So my graph look like this. Second equation, I'm going to use a different color so that you can see it more clearly. And I'm choosing it to be red. So for this one, I have y equals x plus 4. Y equals x plus 4. That means our y-intercept point is going to be positive 4 with a slope of right 1, up 1. Right 1, up 1. So at this point, do you see that it does indeed actually intersect with this first equations? So let me just finish the graphing here. So on your paper, it will be easier for you to graph. I'm just graphing on the screen. And I did a pretty good job that the equation is passing through this particular point. So do you see that the two lines is indeed intersecting at location of 1, 5. So this would be the ordered pair that these two lines intersects. So I'm also introducing the concept. What does exactly the solution set mean to a linear system equations? It's actually you are looking for the intersections of the two lines where the two lines meet each other. So the intersections of the two lines. And in this case, we have 1, 5 as the intersection solution set. Number 4. Find the point of intersection by creating a table for both equations. So it's the same question as the previous one, but this time we're going to use the table method. So what are the points would you like to plug it in to calculate? Well, most of the time we calculate numbers around the point of origins. So for the demonstration purpose, I'll just gather some points around the point of origin. So for example, my x is going to be negative 2. My y is going to be negative, my x value is negative 2, negative 1, 0, 1, 2. And I'll do the same thing for the other equation, negative 2, negative 1, 0, 1, 2. And then let's calculate the values. So how do I calculate it? I simply plug it in and then solve for the y. So 3 times negative 2 plus y equals 1. So my y value is going to be positive 7. So that's our first point. I wrote the wrong number. Second one, when x equal to negative 1, so 3 times negative 1 plus y equals 1. My y value is going to be positive 4. Next one, I like the next one. Why is it? Because it's going to be our y-intercept point. 3 times 0 plus y equals 1. So my y is going to be 1. Next one, 3 times 1 plus y equals 1. So what's my y value? Y is going to be -2. Three times 2 plus y equals 1. So my y is going to be -5. So we have the information for the second set. For the first equation, now I need the information for my second set. And I'll do exactly the same thing. Let me draw a line to separate from the first equation. So y minus x equals 5. So I'm going to plug it in when x equals 2. So y minus -2 equals 5. So this is basically y plus 2 equals 5. So what's my y value? Subtract 2 to both sides. My y is going to be +3. Next, we have y minus -1 equals 5. So y plus 1 equals 5. That means my y is going to be +4. Next one is my favorite, y-intercept point. So y minus 0 equals 5. So my y equals 5. Followed by y minus 1 equals 5. So my y is going to be 6. And then next one we have y minus 2 equals 5. So my y is going to be +7. So we calculate 5 points. Are there anything that you see in common? It happens to be that this point, -1, 4, -1, 4, are both the same points showing in the tables. So what conclusion can we say? So it's basically -1, 4 is the solution set. Think about at this point for a moment. Is there any kind of flaws when you're trying to use graphing method or table method that we did in question number 3 and number 4? So by flaw, I mean, could there be any kind of things that when you're trying to solve the problem using graphing method or table method that will affect your result, the accuracy of your result? So think about these questions. For both of the equations, both of the method that we shown in number 3 and number 4, is there any kind of mistake if you make, and then that would affect the accuracy of your result? We'll talk about it more later. So think about it and then practice the problems. We will work on the homework assignment when we come back to school the next day.